Good morning. Hi guys. Today we're going to talk about 3-4 direct variation. Y equals kx. Now, a couple things you need to know. Y equals kx is a formula. K is the constant of the variation or the constant of the proportionality. That comes back in 3-6 when we talk about proportional relationships. Y equals kx. What does it look like if that's just a formula? What it looks like is y equals 3x or y equals negative 1/2 x, y equals 2/3 x. They look something like that. So the y and the x have to be there, but there's got to be some number. Now, hopefully you know and you realize that if I had y equals x, then k equals 1. Okay? But it's got to be y equals some number times x. That number is the constant of the variation. Now, in example 1, all they're trying to get across is that the constant of the variation is the slope. Okay? K equals m. K is constant of variation, m is slope, Montier. Okay, French. Okay? Example 2, they get into drawing it. Now, since K is the slope, we can use that idea of rise over run. Now, I did show you in my notes that if we put it in standard form, C equals 0. And if C equals 0, that means it goes through the origin. Okay? So I always have a starting point at the origin. Okay? Direct variation always goes through the origin. Now, my slope, I want to think about it as rise over run, and that's going to be negative 6 over 1. So that means I'm going to go down 6 and write 1 because the 1 is positive. So I go down 6, write 1, make a dot. Now, hopefully, you're smart enough to realize that, hey, this is equal to 6 over negative 1. So I could go up 6 and left 1. Now, the significance of this, you might not think it's a whole lot. But later on, you need that flexibility. Okay? And sometimes your graph doesn't go down 6 more because you really should have 1 on either side of the origin. And look, I found a ruler. Okay, and then I draw my line. So I need 3 points, 1 on either side of the origin. So I had this one up here, the origin, this one down here. Okay? These are the easiest ones to graph. When it's an integer, you just make it into a fraction. Okay? What if I had 2 positives? What if my slope was 3/4? Well, that means up 3, right 4, but that's also equal to negative 3 over negative 4, which would be down 3 and left 4. Okay? Now, the concept summary, and the only reason I talk about it is because that's a visual check. When K is positive, you're going to have an increasing slope every single time. A positive number will always give you an increasing slope. When K is less than 0 or negative, you will always have a decreasing slope. Okay? So that's a good visual check. Moving on to example 3, it says suppose y varies directly as x and y equals 72 when x equals 8. Obviously, we're not going to graph this. Okay? But it's the idea that I can find what K is, okay? Because 72 equals K times 8. And you know, you can tell me already, K is 9. That's the constant in my variation. And that's where some kids stop and I have to take off points because that's not direct variation. That's just K. Okay? Direct variation has to have a Y and an X. This is my direct variation equation. Okay? Now, then it says to find X when Y equals 63. So if Y equals 63, then I just use my direct variation. 63 equals 9x, so x has to equal 7. Does that make sense? All right, let's do the guided practice. The guided practice says, suppose y varies directly as x and y equals 99 or 98 when x equals 14. So that means that 98 equals k times 14. And you could use your calculator and divide and find that k equals 7. Well, that means that my direct variation equation is y equals 7x. Okay? So that idea is important. And then it says, find y when x equals -4. Well, that's easy because you just multiply. Okay? Example 4 is just a real life problem, and you can see that in my notes. Okay? It gives you a couple of different equations that are real life examples of direct variations. So do make sure you look at that. Okay? We'll talk to you later. Bye.